This looks okay. But notice, and we should check it. Just select data, and we can see that this is the X, this is the Y. Yep. And you're thinking, wow, that looks bad, because if you think about it, this is supposed to be level, and it shouldn't have much change in velocity, but we look here and we notice that it's not starting at 0. Sometimes it's a good thing to zoom in, but mostly you want to at least start out with 0 so you get a sense of what's going on. And let's see, design, the tab up here, design. So let's see, axis. This is now we just put whoops, where's that going? Oh, look at that, I never knew you could do that. See, I'm typing up here. Time, seconds, and now we want to insert let's see, axis, title, vertical. Wow, all these years I've been using it. So this is velocity, and it is velocity because there is plus or minus to it. cm per second. Okay, nice, huh? So far so good. So now we need to see if I can get this stretched out. We need to do our straight line fit. So we need to put over here the slope equals, and it looks like it's negative, and it doesn't look like much, so I'm going to call it negative 0.1, and then the y-intercept. Hopefully this isn't foreign words to you, huh? And oops, this looks like 5, and we see that needs to be a little bigger. Okay, so we got our 2 parameters. So let's go ahead and let's make the fit line, and that's going to equal, remember the model, y equals slope times the x coordinate, which is time, plus the y-intercept. So it's going to equal the slope. Now we're going to do a little trick here. We're going to use, to make this easier to copy to below, I'm going to not use $2 signs. I'm just going to use, I'm going to keep hitting the F4 key. See how it's changing in different kinds of combinations of dollar signs? So all we wanted to do is always use the M. Now let's think about this for a minute. When we go downwards, no, it's going to do that automatically. So we wanted to always use the 6. I could be wrong. We may not be able to get away with this. Let's test it. I just want to see if I could try something new. So this is our t coordinate, the center of the pair, and then plus the y-intercept, and we hit the F4 to get the same thing as before, to 7. Yeah, because if I do everything in column H, it'll always stay with column M. Without the dollar sign, it's called relative addressing, and with the dollar sign, it's absolute addressing. Okay, so if I pull this down, let's see, M6, yep, and it's using the time over here. Nice. Okay, so now we want to select data series, data we want to add, and that's going to be our fit line. And our x values are going to be these times once again. And now the y values are this fit line we created. Say OK. All right, so now we have to format this. So we can just double click on the chart just to be safe. So we want to format the data series. Oops. Let's move this over here. It doesn't have a title. Okay, so we want to format the fit line series. There we go. So we want a line. And I always like to make fit lines red. And we want it to be nice and thin. And then marker, no markers for the fit line. And there we have it. And so it looks like that's too much. So let's say minus 0.05. And it's getting closer. And minus 0.04. And so on. Okay. Now, let's add something new. And what this is called is the residuals. And the residuals are, if you might recall, when you do a fit with a piece of paper. Now these dots are pretty much a straight line because I created the data artificially. But normally what happens is that these things will be sort of spread around a little bit. And then you might recall that the rule for this is to draw a line. And let's see if, where are they? Nope. Interesting. Maybe just because very weird. Drawing on shapes. There we go. And what you're told is to draw a line where you have equal numbers of dots above and equal number of dots below, and then the distances between them, like the amount, if you took the amount of distance from the fit line to the point, and then that would be a positive distance, and then the ones are negative distance below, they should basically sum up to 0. So not only do you get the equal number of, and it's not exactly equal number of points above and below, but the distances between them are about even. And that, the way you express that is what's called a residual. So you subtract the, so residual is equal to the data minus the fit value. So if they're positive, they're above the line. And if they're negative, they're below the line. So at this point, all the red dots are, blue dots are above. And again, they're pretty much a straight line, but see now the residuals all become negative. Now, without going into it too much, well, one thing, okay, so forgive me. If we follow through on this thought, we can, we say, oh, well, that means that if I make a sum, and that's what this sigma, big capital sigma means. If I sum the residuals, because remember I said the amount of the sum of the spaces above should equal the sum of the spaces below. So gosh, why don't I just sum the residuals? And then I can just, what did I say? Something like that. And it got smaller. Ooh, so I need more decimal places. Right, so we should make sure number. So negative 0.005. Yep, got better. If I double click, I can just edit it directly. And oh, looks like I don't need to have that many decimal places. So let's put a 1 there. And eventually, you see, we can get it to go down to 0. But watch this. This is pretty funky. So I'll show you why there's a weakness to this. So let's make that really, really radical, right? So let's make the y-intercept, let's see, minus 10. Whoops. Minus 20. And notice that the residuals are actually getting smaller and smaller, the sum, huh? And this is a case where I have to make the demonstration. I have to make this auto. Now, notice that, let's try minus 55. Whoops, so it went above. So minus 51. But you can see that I can now get the sum of the residuals. I can bring in the 0, but the fit stinks, right? And it's not the end of the world if all we ever did was to hand type this in. But at some point, we want to learn how to program Excel, to find the best fit for us. And to do that, we need something, because computers are dumb and they can't actually see the plot like we can. We need a better figure of merit, and that is going to be the residuals squared. So now we say equals this guy squared, and then we fill it in. And then notice it's 0 in the middle. That makes sense. So now we're going to say that this is the sum of, let's get that fancy symbol again. Sum of the residuals squared, and equals sum of all these guys. And notice that's a monstrous number. And if we go back to what we had before, minus 0.01, and make this one 5 again, that now both of them are beginning to approach each other. And so the residual squared is a much better number. And in this case, since it's artificially created data with no errors, that these residuals squared themselves and the residuals are going to get to be quite small. And I just realized that, see, I haven't remade that 0. This one actually makes it easier to do because let's add a 5 here. Oh, wow. Got it in 1. So now once I've gotten it, I can just reset this to 0. And now we have our finished graph. Now, hopefully you've said to yourself, hey, wait a minute. If the acceleration is 0, which I expect it to be if I have it level, because that would mean that when I let go of the sled, it won't move. I'm actually seeing that even when I send the sled going off to the right, it slows down ever so slightly. So what we do then is, well, let's tidy this up. And let's put our grid around it. All borders, we got the units, and let's make sure that we format them as numbers. Yup. And then these guys I just added extra digits to, and the same with these guys. It becomes easier to do that when you're doing real fitting. And so again, we know if we did our pre-lab that this is the acceleration in centimeters per second squared. And we're dismayed because it's not 0. But let me think about it for a minute. Yeah, we're dismayed it's not 0, but we aren't done yet. So this has already gotten up to 32 minutes, so I'm going to stop it and restart it.